Yeah, hi. In this video, we will quickly discuss about some embedded software tools. Okay, so what are the different software tools we'll be using? So probably we are getting this in the ID. Okay, so ID will be providing all this like all these tools, or maybe separately if you want, you can install it if it is required, right? So let's quickly discuss about the first tool is the text editor. So what is text editor? So basically text editor will be the platform. Okay, so where we will be typing the like code, right? Where we'll be typing our like program. Okay, so text editor will be the first tool you need for embedded software development. Okay, and this is where you will write the code for your embedded system. So this code will be writing, as we discussed, it can be like done with any programming language, C or C++, whatever it is. The code written in the editor is also referred as the source code. Okay, so whatever code we are writing using any programming language, we'll be referring that as the source code. Now let's see how we will be converting the source code to the machine code. So what are the different stages involved over there? Okay, so what are the tools involved over there? Maybe as I told already, the ID directly converting the source code to the machine code. So maybe in between different processes are happening. For this different processes, different tools are required. So we are actually defining, or maybe we are discussing about the tools. Like even in the last lesson, I told that for the host machine, you can use the different software development tools, and for the target machine, we can't use any software tools. Okay. Now let's move on to the second software tool, that is compiler. So what do you mean by compiler? It's very important term, like it's very important term in embedded programming. Okay, so embedded system programming. So compiler, okay, so that is the second among embedded like a system development tool. Okay, so that is compiler. Compiler is used when you are done with the editing part of the code. That means once you written the source code, now the compiler is coming to the picture. So the compiler function, okay, so the function of the compiler is to convert the source code into the object code, right? The source code, that means the source code, if it is written in C program, so we'll be calling source code as the .c file, or if it is C++ .cpp file, right? So this code, source code will get converted to the object code. This is done actually with the help of compiler. All right. So object code is understandable by the computers as it is a low-level programming language. Okay, so still it's the computer, maybe that is actually like understood by the computer. Maybe the high level is not exactly the same. Okay, it can understand. That means as a developer, we can understand the high-level language code, but not the object code. Object code is for the computer. High-level language, that means the source code is for the developer or humans. Okay, so that's in the human readable format. Right. So we can say that the compiler is to convert the high level language code into the low level programming language. This is actually done with the help of compiler. Like still it's not the complete machine code actually. Okay, so again some stages will be there in between. All right. So what is compiler? Again, I'm concluding that compiler is something which is converting the source file which is written on C or C++ language. Okay, so that is actually getting converted to a low level language. So that is object code. Okay, so that is getting converted to object code which computers can read or they can understand. Okay, so they can actually go through the object code. Right. So this two tools, I hope it's clear for all. Now let me show one diagram. So this diagram explains more. Okay. So initially we'll be writing the source code. So that can be written any programming language. So after that the pre-processor stages will be there. Okay. So this is actually the procedure, or this is how like a normal C program, how you are converting finally to the executable format. Okay. Yeah, so as usually like we are writing any program. Okay, so any C program if you are like doing for the host machine, so the different compilation process I am talking, it's not only about the embedded software, like generally how the C program is like actually how it is going through the different stages or different processes. That's what we are discussing. So the source code once we written, then the pre-processor stage. So what is pre-processor? We'll be discussing that in the course. Okay, but at least what is the preprocessor stage, what it does. You may have seen that like we'll be writing ash include, right? Ash include iostream.h, stdio.h. So this ash include stage, okay, or maybe sometime we used to write ash define, right? So macros we used to define. So all this is are coming in the preprocessor stage. What it will be? Like in preprocessor stage, you will be defining any variables or you will be defining any functions and all. So in short, I will just tell you that preprocessor stage is something like where the code expansion will happen. Okay. For example, if I written my code for 5 lines of code I written. So in the preprocessor stage, any function, that means any macro, like in macro, if you have done any function or if any variables if you define like in the macro, so all will get replaced there. Okay, so the code size can increase. Maybe like whenever I am discussing about the like macros, I'll be showing the practical example, so it will be clear. So this is how the initial stage will happen. So that's the pre-processed code. So that will be the like that of course will be like more number of lines than the actual code. Right. So now actually this we are feeding to the compiler. So what compiler does? Okay, so the expanded source code. That means after even preprocessor, the like the code will be calling that a source code only. Okay. Yeah. So the compiler will be converting the expanded source code into assembly code. Okay. So assembly code. That's why I told it's not a complete machine code. It will be like assembly code. And again, after compiler, there is one more thing that's called assembler. Okay. So assembler always will be taking assembly code as the input and it will be creating the object code. Okay. So compiler and assembler, they are actually connected together. So the compiler will be like we will be feeding the source code. Then after compiler, then again assembler. Then after assembler, we'll be able to get the source code. Sorry, source code was already converted to the object code, right? So this is happening like in multiple stages, right? And finally, this object code I told it's not a it's not a complete code. It's not the end code, right? So why it's so object code is of course a low level programming like low level code. Okay, low level language code. That is fine. But again, the linker will be coming to the place. So what do you mean by linker? What linker does? Okay, sometime what we'll write, like maybe it's a teamwork, right? So multiple people will be working in a project and they individually will be developing different .c file. That means individually they will be writing source code. So different source code they will be writing, and finally they would like to club all together and they want to like they want to make the executable code. So this actually like linker will do. Okay, so linker will be helping in these stages, and even sometime the libraries and all we want to include. For example, if I am using any string function, for example, string comparison, strcmp or string length. Okay, so this kind of functions if I am using, I am supposed to add the header file string.h, right? So all these libraries will be getting added in the linker stage. Okay. Then after that we are getting the executable code. Okay, .exe file, which is like the application which you can run, right? Usually we are downloading, right? Any application if you want, we are actually downloading that in the .exe format. So from the source code, we started our planning and finally we made the .exe file. So if the .exe file, you can actually transfer to like somebody else. Okay, you can maybe transfer even to some other devices or anything that you can do, right? Yeah, so now assembler we discussed already the actual definition. You can see the assembler will be converting. Okay, so the function of the assembler is to convert the code written in the assembly language to machine language. Okay, and all the mnemonics and data will be converted to the opcodes and the bits by like opcode bits by the assembler. I'll be showing what is opcode and how it is looking. Okay, so like that the stages will analyze. Then finally, maybe like a debugger. So debugger session, we haven't seen that maybe in the process, but debugger is must, right? And why we are using debugger? It's very simple. Debugger is a tool used for the debug your code. Of course, whenever like even though you are an expert, you are writing the program, of course, there can be some errors, right? So possibly initially we'll be getting any syntax error or logical error. Okay. So this all can be we can make the code error free with the debug tool. Okay, debugger tool. And it's like it's our duty to ensure that the code whatever we written that is error free. So most of the IDs will be like that will be giving the like a debugger. Okay, so we don't want to install anything separately. So debugger will be going through the whole code and test if the errors and bugs, if it is there any errors or bugs. Okay, and like even the debugger will be able to identify if there is any runtime error, okay, or syntax error. So syntax error and all we can actually get it easily and we can correct it. Like most of the IDs, even while writing the code, if there is a syntax error, they used to like give some warnings and all, maybe some red marks will be there. So from there itself we'll be able to understand that syntax error can be there and we can correct it easily. And some like runtime errors will be there, so that like maybe during the compilation process we'll be able to understand. Okay, so some technically some logical errors and all maybe on the host machine even we won't be able to find it. So once you are actually implementing that to the target machine, so sometimes some errors will be there. So that is actually very difficult to find. Okay, so some errors with the like related to the hardware or even related to the logics and all, so that even we can solve it only with the like the real testing. with the real hardware testing, we'll be able to solve it. Otherwise, most of the task we'll be able to do with the help of debugger. Right? And as I told already, linker. So in the linker stage, we know like multiple source file will be there. This is important concept why linker we are using. As I told, it will be a teamwork. Okay, so different people will be working on different areas. Okay, all will be having their own source file and they will be converting that to object file. And finally, all these object files need to be clubbed together for the complete embedded application. Okay, so sometime even will be having some libraries we want to include, as I discussed earlier. So finally, after collecting all these things, we'll be finally getting the executable program. Okay. So linker is a computer program. Of course, remember linker is not a special hardware or something. Okay, it's a program itself. It will be a program written in C language or anything. Okay. So linker is a computer program that combine one or more object code files and library files together to make the executable program. Right. Like it's even if multiple people are not working, still what we can do, it is very common practice to write the large program into smaller parts. Okay, we'll be breaking that into modules and we'll be writing the program. Why it's so? Because it will be easy for us to identify if any errors are there. For example, if I'm making the temperature example only, I'm telling. Okay, so if I'm actually like reading the temperature data and I'm displaying that on LCD. So for LCD, you need separate functions and all. Okay, if you want to display some LCD data, if you want to display some data on the LCD, we need separate functions, setting the cursor position. So many things we have to take care over there. So what we'll be doing, we'll be writing the LCD program separately and reading the temperature from the sensor and converting that to digital format. Okay. So even to get the proper data, maybe if you want to, you can convert that into degree centigrade or Fahrenheit. So this will separate. We'll keep it as a separate module, reading the temperature and converting that into degree centigrade. So this two will become independent modules. Okay. So then finally, I would like to club all this together. Then I'll be making the executable code. So that time linker will be very like useful, or it's very like a helping tool for us, right? All right, so this were actually the different software tools we are using in the C programming or embedded C programming. I hope all are clear. And most probably the kind of IDs and all we are using, they are not like insisting us to like add everything separately. Most of the IDs will be having the compiler, debugger. Okay, most of the things together will be already incorporated. If it is not there, we'll be adding that. Okay. So that's it. I hope all got a clear-cut idea about the software tools we are using in embedded system programming. At least be familiar with the terms like linker, compiler, assembler, and all. Right? All right. Thank you. Thank you all. Let's meet in the next coming lesson.